Hey my JEE warriors, welcome to the NCERT underline, where we will do lots and lots of questions on electrostatics, capacitors and current electricity. And all my warrior pandus, are you whistle doing already or not? Let me know. Completely based out of NCERT, and this is your 12th standard topic, and many of you are right now preparing for boards. So the best way to read NCERT is to make it into a fun quiz, to make it into a question book and cover all the important lines of NCERT, and that will not only help you for your boards but also for the next attempt of your JEE examination. So I hope I am audible and visible. Do let me know in the chat box. Very good, very good, very good. Looks like we are awesome. So let's begin with the session, because there are a lot of questions, and yes, to show your support for your captain, for your thalaiwa, for your navigator, for your master teacher. Show that support and show that love out there. Yes, right now in the towards the comment section, you will see the like button. Just smash that like button and also hit the subscribe button right away right now. Okay, so just do that quickly. So let's begin with the lecture. Let's begin with the class. Just one second. Okay, let's do this. Yes, will it help for NEET? Yeah, it will help for NEET. It will help for JEE. But the main target is, remember, to master NCERT from JEE point of view and also your board's point of view. So let's keep a balance of it. And let me tell you, in the description box, there is a link for the free test series for your next attempt. Okay, as well as for your board exam. It's a completely computer-based exam. So for class 12th, there is a test series. The link is there in the description box right away right now. Make sure you have enrolled via the link which is there. Okay, it's a completely free of cost test for your board exam. Okay, so let's begin with the class. Here comes the first question. You guys have to be really fast. Okay, are you ready to do 50 to 70 questions at least? Let's target, lots of questions within 1 hour. Let's keep it like a rapid fire. Let's keep it really quick. Okay, either you know it or you don't know it. If you don't know it, mark it and study that. Mark it and study that particular point. Okay, what is the SI and CGS unit of electrical charge? Come on, quickly post our answers in the chat box right away right now. Waiting for all the answers. Everybody should spam. Even if you're wrong, it's okay. Good evening, Henry. Hello, Lavanya. Hello, Mutil. Hello, Janani. Hello, Stenice. Hello, Kishore. Hello, Satish, Denzi. Welcome. Yes, one is basically Coulomb. Coulomb is SI unit. And the CGS unit is ESU. Many people do not know the CGS unit, ESU, and one SI unit is 3 into 10 to the power 9. 3 into 10 to the power 9 ESU. 3 into 10 to the power 9. Know this conversion factor. If it comes directly, you will not waste time. Else you will spend a lot of time converting it from current and other things. You will have to do that conversion. Okay, you will have to use other things to convert it. Okay, chalo, let's move on. Electric field, you have to fill in the blanks. All questions are fill in the blanks. All the questions are fill in the blanks. Okay, NCERT lines for your boards as well as JEE. Electric field intensity at a point is defined as the force per unit what? Think, acting on dash charge placed at that point. When you talk about electric field is force per unit test charge. So force per unit charge acting on a, and always by convention you take a positive test charge. You will always take a positive test charge, not negative. All right, yes, and it has to be a positive charge. Very good, Madhumita, very good. Yes, Frank, I'll be telling you all the important NCERT underline things. And regarding problems, a lot of you are asking, sir, NCERT back exercise, can you do something for us? I have a massive free surprise at around 8:30 or 8:15. As soon as this lecture is over, I'll be coming up with a massive surprise for your boards, especially the NCERT problems, back exercise questions. Okay, so wait for that. Okay, Frank, I hope that is okay, bacha. I hope that is fine, Pasangla students. Yep, very good. Next one. The direction of the electric field at a point is the direction of the dash experienced by a dash placed at that point. By a dash. Come on, think about it. What do you think should be the answer? The electric field, the direction is the direction of, is the force per unit charge. So the direction of the force is the direction of the field. And not just that, experienced by what? Experienced by a unit test positive charge. Unit test positive charge. Yes, that is the correct answer. Very good. Excellent. Force is there and your positive test charge is there. Moving on to the next one. If you have many charges, Q1, Q2, Q3, the total field at a point is the dash sum of the field due to each charge. Is the dash sum. That means you add something. If you have many charges, the total field at any given point, the total field at any given point is just the vector sum of the electric field. Yes, not any random addition. It is the vector addition. E1 bar, E2 bar, E3 bar, E4 bar, E5 bar will give you net E bar. Correct. When electric field due to a point charge Q is at a distance is given by this formula, where the value of E is in which unit? Question is, what is the unit of electric field? Very straightforward. There are two possibilities in this. There are two answers. I want both the answers. There are double units of electric field in that too SI. You can use any one of them. One is, if you remember the formula, force by charge Newton per Coulomb. Newton per Coulomb. That is one unit. Second unit, electric field is dV by dr with a negative sign. dV is volts, R is meter, so volts per meter. So Newton per Coulomb or volt per meter, both are correct. Both are correct. Volt per meter, yes Hariharam, very good Ben. Yes Madhumita, Newton per Coulomb and volt per meter. I wanted both the units. It can come as a multiple choice as well. Okay, moving on, next one. The dash of the dash in the electrostatics states that the total electric force on a charge is the vector sum of the forces by all the charges. So if you take a charge, the total force on a charge is the vector sum of all the forces F1, F2, F3, F4. If you add them vectorially, you get the total force. The dash of the dash in electrostatics tells you about it. Who is that? Who is that? Come on, think about it. Who is that? Think about it. Sam Jershi, let me tell you, there is a JEE crash course which is going on right now, which prepares you not only for the second attempt and the JEE Advanced, but also for the boards. So for the summary, my humble request is please be a part of the crash course. You have, special CBSE teachers who are going to revise all the chapters with PYQs and help you with your board preparation. So my humble request is be a part of the crash course. All the lectures, all the chapters are going to be covered for your board examination. Okay, great. What is the answer? The principle of superposition. Yes, that's the principle. Principle of superposition is the correct answer. Not additive property of the charge. No, that's not correct. Superposition says you can add all the forces irrespective of how many charges are there and they do not interfere. They will produce a combined effect. That is why they are said to be superimposing. You are adding all the effects. Great. Next, the electric potential at a point is defined as the electric dash per unit dash at that point. Think what will come. This is going to put a lot of I would say a load on your brain thinking power because you don't have options. And I want you to get used to this because when you have options, you're always trying to eliminate or select. But when there are no options, your brain thinks even more and there is a good chance you will be able to remember all these lines when you write definitions in your board exam. And also, it is going to help you in your second JEE mains attempt. What do you think is the correct answer for this? Come on. If you say boards is simple, you have to get 75% at least. We need to get through this. Yes, electric potential is the electric energy, which is joules per coulomb, that is per unit charge. So it's the amount of the electrical energy which will be there per unit charge at any point. That is what the potential is. Yes, it's not per unit length. It is electric energy per unit charge. Joules per coulomb is a volt. Joules per coulomb is a volt. Okay, many of you went wrong about this. Many of you got a wrong answer. So be very, very careful. Let's go to the next one. It's okay. Gather yourself up. Read the question. Answer in the chat box. The work done in moving a unit positive charge from infinity to a point in an electric field is known as what at the point? What do you call it? Come on, think about it. If you take a charge from infinity and bring it to some point, you do some work, and the work done in moving that positive charge at that particular point in a field is called as the electric field at the point. No. It is the electric potential at the point. It is called as the electric potential at the point. Is that okay, my dear warriors? Very good. Volts is joules per coulomb. Work, joules. Charge, coulombs. Joules per coulomb is the volts as that point. Next one. If two charges separated by a distance in vacuum and the charges are doubled, the force between them will be how many times the original force? Recollect the Coulomb's formula. F is Q1, Q2 by R square. Q1 is doubled. Q2 is also doubled. The numerator is doubled 4 times. So if the numerator becomes 4 times, naturally the force should also become 4 number of times. Answer is 4. Just check this out. Excellent. Some of you are really quick. No, the answer is not doubled. Answer is 4 times. Yes, very good. Yes. Shanmugan Raj, like I said, you are going to have the specialized teachers, right, in the course, and we too will be there for some lessons, like I promised. Don't worry, my dear warriors, okay, because you need to have those specially trained teachers. Even, let me tell you, I will not be really comfortable, taking all the lessons in the crash course. I might be able to take it for 3 months or 5 months or even 1 year, but for crash course you need to have those special teachers who can actually train you in that short time. That is what I recommend personally. Right, moving on. In a uniform field, the lines of force are dash and dash spaced. Interesting, there are 2 filling the blanks. There are 2 filling the blanks over here. In uniform field, the lines of the force are dash and dash spaced. What do you think should be the right option over here? Yes, they should be equally spaced, definitely. And the lines of force, because they are equally spaced, how will they look like? They will be parallel to each other. They will be parallel to each other, and they will either diverge or it will converge. Diverge or converge. Yes, that is the way you have to think. Parallel and equally. Very good, Aditya. Yes, Madhumita, I know you guys love me. Definitely. That's the reason why I'll be also there for some classes. Don't worry. Electric field inside a conductor in electrostatic equilibrium is always electric field when it is an electrostatic scenario. That means electrical equilibrium is there. Then what kind of field is there? Then the field inside the conductor is 0. It should be a big fat 0, right? There is no field only inside. Outside there is field, and outside the field lines are perpendicular. If you remember, that is one of the properties of a conductor. Right, moving on. If you have a parallel plate capacitor with plate area A and separation D has capacitance given by what? Where epsilon naught is what? 2 filling the blanks. 2 filling the blanks. Very good. Now I can see all the zeros in the options, answers in the chats. Very good. Very good. Keep it up. What do you think is the right answer for the formula of capacitance for a parallel plate? Parallel plate, area is given, D is given. Epsilon naught into area divided by D. D is the distance between them, and epsilon naught is the permittivity of free space or permittivity of vacuum. Permittivity, how much is it able to permit those electrical field lines inside any medium? For free space, it is 8.85 10 to the power minus 12. 8.85 10 to the power minus 12. Next, Gauss's law states that the total electric flux in a closed surface is equal to 1 by epsilon naught times the dash enclosed by the surface. 1 by epsilon naught of what? Gauss law, total flux is equal to something by epsilon. Something is Q in. What is that Q in? Q in is the total charge which is enclosed. Exactly, the total charge which is enclosed, or the net charge which is enclosed. Perfect. Moving on. Electric potential at a point due to a single point charge is dash of the charge. Very interesting. You can think of many things. You'll be like, sir, I can think of so many things. But yeah, more or less, if you are correct, I am okay with it. Or even if you think a little bit differently, that's also fine. But see, if this was one of your thoughts when I show you the answer, what are the different things that you can fill in the blanks? Okay. Electric potential at a point due to a single charge is independent. Oh, the word came naturally. The word came naturally in my head. Oh, independent of the path of the charge. Yes, if you get to a point, no matter how you come to that point, doesn't matter how you come, independent of the path taken by the charge, as long as you come to the same point. Yes, independent. Yeah, confused, right? Little bit confusing. And that's the reason why I told you filling the blanks are real fun, especially for NCERT. Let me tell you, many teachers, what they do, they open the NCERT, they underline. This is what it is. Read this, okay. Next page, read this, okay. This is very, very important. I can also do that, but it will become very boring. You will be like, what is this underline? But when the underline is in the form of filling the blanks, that too without option, that is fun, and that's exactly what you are enjoying right now. So smash the like button down there for your Captain Shreyas and share the word with your classmates. Anyone who is your friend, maybe not your friend, anyone, just share it. Tell them Captain Shreyas Sir is doing this, that too for all the students who want to learn in English. Absolutely free of cost on YouTube, on their channel. It's your channel. What is it called? Vedantu JEE English. Subscribe if you have not yet done that. In a non-uniform field, the electric field lines are non-uniform. That is a worst also. Yes, and that is also tricky. Correct. Correcto. What do you think is the correct answer? Think. Yes, very good. Some of you have got it. In non-uniform field, that means the field lines will be diverging or converging. That means they are not parallel. They can also be bent like this. They can also be bent like this. Non-uniform, right? So they can be curved. They can be non-parallel. Both words are correct. Very good. You have to think out of the box. What are the different possibilities that will fill or match in that blank? Energy stored in a capacitor is given by a very simple formula where U is measured in joules. Many formulas are there. There are 3 ways of writing it. Let's see how many of you can write all the 3 different ways of writing the energy stored in a capacitor. The 3 different ways. Electric field lines never intersect. That is irrespective of the fact whether they are uniform or non-uniform. So what is that special thing in non-uniform? They are not parallel and they are curved. So the electric field lines anyways don't intersect, whether it is uniform or non-uniform. So that won't be the defining or distinguishing factor. Yes, one is half CV square, very good. Some of you would have got it. Yes, half CV square. Another formula is half Q square by C. Half Q square by C. And another form is half charge into voltage, half QV. All the formulas are correct. Half CV square, half Q square by C and half QV. All the 3 different formulas you should know. Next question on your screen. Property of a material to become polarized in the presence of external field is known as... What is that property of the material? What is the property of the material which makes it polarized when you apply a field from outside? External field comes, the material becomes polarized, positive, negatives, dipoles are formed. What is that called? There are dipoles created, polarities are created, dipoles, dielectric polarization. Exactly. Dipoles are formed, that's why it is called dielectric. Okay. Many people ask me, sir, why the name dielectric, sir? Sounds so negative. That die came from, not that die, it came from Di means two. So polarities are formed, positive, negative, dipoles are formed. That's why that name came, dielectric. Okay, a line of force in an electric field originates, very simple, originates from dash, terminates on dash. I want everybody to spam this. Yeah, Uchuk, this is also going to help you for your mains second attempt. Many of you would have realized they are asking many questions from out of NCERT, right? Especially in chemistry and even in physics. I saw such laddu questions which are asked, and you are a part of all the discussions. So let's make it so thorough that anything asked from NCERT, those marks are in your pocket. And there will be exclusive other JEE sessions also where we'll be concentrating on beyond NCERT questions also. But I want your entire grip on NCERT right now. It should be in your hands. You should know each and every page, how it looks like, how the tables look like, what are the lines, what are the definitions, what are the questions. And I'm going to reveal a massive surprise tonight after the session immediately. So be there. Yes, the answer is positive and negative. It starts from positive, goes to negative, very straightforward. There is one thing which is commonly mistaken and many students get it wrong. When there is a dipole, when there is a dipole, means minus and positive charge, where is the dipole moment going to go from? The dipole moment goes from negative to positive. Be careful. That is the dipole moment. Many students get confused. They say dipole moment goes from positive to negative. No, dipole moment goes from negative to positive. Field goes from positive to negative. Two different things, don't get confused. Two different things, don't get confused. Moving on to the next one. Coming up on your screen, the process of transferring charge from a charged object to the earth is called as, come on, yes, Advait, if you get 95% in boards, I think you will be one of the toppers, no, in your school at least. Yes, dipole moment is by again convention. Yes, definitely. I know, Uchuk, even I am waiting for those sessions. I also want to get done with boards, yeah, very quickly. See, it's like one thorn in the neck, or you know, it's like a pill which we have to take. You have to cross this ocean to reach to the other side. Just like Columbus had to cross so many oceans to reach to the newfound land, same way we have to cross the ocean with lots of, or maybe not lots of, little bit of hurricane, a little bit of stormy weather, and that's it, and you will be on the other side. The other side is where the main battle has to be fought, and that is your JEE. Remember that. It's not the boards which is going to be the main problematic thing. But having said that, many people take it casually and they end up getting 74 or 70% or 60%. Please don't do that, yeah. At least aim for 90%, you will at least come to 85%. Okay. So the process of transferring a charge from a charged object is called as grounding or earthing, as simple as that. Yes, very good. Sobita, Sujit, awesome. So many of you got the correct answer for this. Next one is, what is the unit of electric flux? I've seen so many kids giving the wrong answer for this, and I feel really pained listening to that. Hello, Homo sapien, nice to see you back. Earthing, grounding. Yes, grounding and earthing. Bhargavi, don't think that, sir, whatever answer you wrote, is that the only correct answer? No. You can have multiple answers correct. I'm just giving you an idea of how you can fill the blank, because obviously your exam is objective. But having said that, you should know what is, how to write the answers for your upcoming board exams. Yeah. Haritaran. I mean, I just don't want to even imagine that student who gets 74.9%. What, I mean, you know, that is the worst. And you know what is also worse? Getting like 89.9 percentile, just barely qualifying for advanced. Even worse, I'll tell you what is the worst of all. And this has happened with many students. This is not hypothetical case. This is real case. A student got 85, 80, 84% in boards. So definitely qualified. A student cleared mains with 97 percentile. Very happy. Then wrote advanced and then got 25,000, 24,000, 20,000 rank. What happened? Boards cleared? Yes. Eligible? Yes. Mains cleared? Yes. Are you getting NIT? 97 percentile? Not that great. Somewhere and all you are getting that too very random branch. Mining and all that. Not even interested. Okay, gone. At IIT, what are you getting? No. IIT gone. For 20,000 rank, you will not get any of the good IITs or even decent IITs, and even the normal IITs, the lower rank IITs, you will not get the good branches. So that also gone. So what should such student do? Imagine. So that is the worst thing, being on the borderline. So always try to cross over that borderline. That should serve as a motivation. Remember that. Okay. The unit is voltmeter or Newton meter square per Coulomb. Yes. Yeah, don't worry. There are multiple options. You can go to private colleges. You can go to other government colleges also. It's not like the life is over. Definitely, there are multiple options. And I will tell you all the kind of exams that you must be prepared for, because all these things can happen, right? And it's not like only IITs and NITs are there. We have so many institutes, and we'll be discussing and we'll be making you prepared for all these examinations on this channel. Be it EMSAT, be it VIT EEE, be it SRM JEE, be it MIT EEE, be it your BIT SAT exam, all these things, or even CUET exam. We will do this on this channel, because if I just do for JEE, then what about those lakhs of students who do not clear JEE, right? We have to think. I have to think. You are my students. I cannot let you go like this. Okay, voltmeter, Newton meter square per Coulomb. That is the answer. Moving on to the next one. The electric field due to a uniformly charged infinite sheet, uniformly charged. What do you think is the answer? What do you think is the answer? Yes. Adarsh, do you want me to do all the sessions like this for all the chapters? I am completing the entire 12th portion in the next 4 days. Yes. So if you want to do that, share this session. Get many students. Comment on this session. Sir, we want this for all the chapters. Like the session. Watch it. Increase the views. Then I'll feel happy. Like, sure, you're doing this for views. Yeah, man, I'm doing this for views also. No, I will only feel motivated. I will feel so happy. Okay, my kids are loving this. The kids are watching it. I will feel happy. If I feel happy, I will do more sessions. So do that. Okay, it's not like I'm charging you money for that. Just watch the session. That's all I'm asking. It's for your benefit only. Electric field due to uniformly charged is sigma by 2 epsilon naught, and it is constant. You can use the word constant also. You can also use the word okay, sigma by 2 epsilon naught. Yes, sigma by 2 epsilon naught. The capacitance of a spherical capacitor with an inner radius A, outer radius B is given by which formula? Spherical capacitor, R1, R2 will be there, or A and B will be there. 4 pi epsilon naught will be there on the top, that's the numerator, and in the bottom 1 by A, 1 by B will be there with negative sign. Yes, 4 pi epsilon naught, you can write it like this, or you can also write it as like this: 4 pi epsilon naught 1 by A minus 1 by B. You can take LCM and you will get exactly this. It's the same thing, right? Everybody, shall we go ahead to the next one? In an electrolytic capacitor, a thin layer of dash acts like a dielectric. Many people do not know this. No. The epsilon naught A by D is only for parallel plate capacitor, not for spherical plate. It's not for spherical tape. Badri, I would say for getting into Ekalavya, I would say at least be above 97 percentile. 97 percentile is generally safe. 96 is borderline. 90, it means you most likely 99% you will be inside only. Okay. In an electrolytic capacitor, a thin layer of oxide. Oxide is the correct answer. Oxide layer acts like a dielectric for a capacitor. Okay. So this is there from NCERT. It can directly question came in your JEE mains first attempt, right? In just January attempt, direct question came on spherometer. So you can have such direct questions from NCERT. Many times they ask value-based, theoretical-based, memory-based questions in physics too. Remember that. A positive charge, when moved along the electric field, the potential energy will. Okay, you are taking a positive charge, you are going along the electric field. Electric field always goes from high voltage to low voltage. High voltage to low voltage. So potential energy, oh my God, what is this? Am I going to teach computer science? No, right? Something happened over here. Can I do this? Oh, thank God. I thought I have to teach computer science also. Okay, so the potential energy will decrease, right? It will decrease. You're going from high voltage to low voltage. going from high voltage to low voltage. So that is basically decreasing potential, because electric field always goes from high voltage to low voltage. Field, high voltage to low voltage, so potential energy decreases. If this was not a positive charge, it was a negative charge, then the answer will be increase. If this sign changes, this will also change. Okay. Next one, electric field line never forms a closed loop because electric field is a dash field. Teach computer science too. My God, guys, I will be teaching you English. By the way, for your English exam, do you know that last year also I taught you English? Obviously, yeah, come on, we are an English channel, we can do that. So how about that? Shreyas Sir, your team is going to teach you also for your English board examination right over here. But not now, not so much in advance. Let's concentrate on JEE. Next week we'll do that. Okay, just before the English exam. Yeah, the answer is conservative because electric field lines are conservative in nature. So once they are conservative, they will never go closed loops. If it is a closed loop, it is a non-conservative field. It is a non-conservative field. It's not about continuous or anything. It's conservative. Electric field is conservative, meaning if you come back to the same point, net work done should be 0. If it is a closed loop, then every time it will be doing some work and the net work in a closed path will not be 0. That's not the case. It should be 0. If there are two capacitors in series, then the total capacitance is dash than the capacitance of either capacitance. Well, whenever you are in series, the net capacitance is given by 1 by C1 plus 1 by C2 is 1 by C equivalent, and that C equivalent, just like in resistors in parallel formula, will be lesser than each of the individual capacitors or resistors. So it should be less than. In parallel, the formula used is C1 plus C2 plus C3. So the total capacitance is more than each capacitance. But in series, the formula used is 1 by 1 by 1 by reciprocal formula, adding. Then the net is less than, it's not more than. So that's how it works. Okay, you might have learned that in resistors too, and same applies for capacitors, but just that whatever you learn for series works for parallel. Here, whatever you learn for parallel works for series for resistors and capacitors. Field at the center of a uniformly charged ring. If you take a ring, all the charges will apply fields and the fields will cancel out each other in all the directions. So the net field must be a big fat 0. Very good. Moving on. Electric field inside a non-conducting uniformly charged sphere varies with the distance from the center. How does it vary? If you take a field inside a non-conducting uniformly charged sphere, inside uniformly, it's like gravity inside the earth. How does the graph look like? Linear graph. When you go outside, inversely proportional to r square graph. So inside it is proportional, outside it is inversely proportional to r square. So initially it is a linear graph, it will be a straight line and then it will go a curved line. How many of you remember this? No, the answer is not 0. A lot of people think the answer is 0. No, it is not 0. It's not a conductor. Please read it carefully. Non-conductor. Number 1. Number 2, uniformly charged. So even inside there will be field. Okay, it's not that the field will be 0. It will be directly proportional. The formula is kq small r divided by r cube. Kq, okay, small r or x divided by capital R cube. How many of you remember this? Yep. Yeah. Malika, I am doing the entire NCERT line by line, and for numericals, I have a surprise for all of you just after the session is over. Okay. And trust me, numericals, you are most likely used to it because of JEE, but even then we'll be doing numericals in a separate set of sessions. Here I want you to get a firm grip of NCERT. Every definition, every line, every memory based question which will be asked in your boards as well as for JEE second attempt or for CUET or for BITSAT or for local CET, we will do it inside out. Nothing will be left. What do you think it is? The answer for this: process by which a charged object transfers a charge to a nearby object without touching. That is called induction, inducing. Yes, very good, Amuta. Very good, Noha. Very good, Vishal. Excellent. Moving on to the next question on your screen. A conductor has a dielectric constant of conductor has a dielectric constant. So this is a very interesting thing. Remember, when you are inside any medium, the electric field is the external field divided by K, right? Now imagine you are inside a conductor. What is the electric field inside? It is 0, right? Electric field inside is 0. So if this is 0, that means this K should be what? The K should be infinity. Very good. Excellent. The K should be infinity. Awesome. That is the correct answer. The conductor has a dielectric constant of infinity. Awesome. Next one on your screen now. The electric field at a point in space can be represented by the density of dash at the point. Whose density? Think. Electric field strength, okay, or the electric field strength at a point anywhere is represented by the density of whom? The flow of solving numericals, lone warrior. See me doing problems. You can watch any of my old classes of any chapter. Use the same problems, solve it on your own without the video. Take hints wherever you are getting stuck. See how I am thinking. Try to do it on your own after you have watched it once. Then go to very easy peasy problems like the H.C. Verma, short answer questions. Then go to some basic questions. Then go to medium questions. Then go to nice questions, and then go to PYQ. So if you go with this flow, I think you will be able to do it. Okay. So what is the correct answer for this? Yes, field lines at that point. Field lines at the point. Field lines, if they are close, the field is strong. Field lines, if they are far away, the field is very weak. That is how it works. And if the field lines are parallel, the field strength will not change at all. Okay. Electrostatic potential is a scalar quantity and is represented in the units of this we have done. Potential is nothing but what? Volts. Yes. Yes, Dikshita will be starting a new series as well, or will be thinking of how we can use the flash series for the second attempt. But that will happen after the boards exam, not immediately right now, okay? Because most of you are right now preparing for boards especially, and I think it will be really dicey because state board exams, CBSE, ICSE, every exam is going on right now. Yeah. Okay. What about the next one? The dash from infinity. Come on. And if you're a dropper student, please watch my older classes. They are also very good. It's not like you would have watched all my classes. So watch the older classes too. Make sure you're up to date. And within no time, we'll be back to JEE second preparation. Although this is also JEE second preparation, but in the NCERT approach, it's a much simpler approach. I would admit it, but I think you need it because it's not like every one of us over here are 99 percentile or 99.9 percentile. So you need to fill in those gaps. So how about revising the NCERT? Let's go from the basics. Let's do it from the scratch. Let's, redo things. Okay, but in a much more efficient manner. The dash from infinity to a point in electric field is known as the voltage. The work done per unit charge. The work done per unit charge. Yes, that's it. Very good. Very good. Excellente. Excellente. Moving on. The potential. There are a lot of filling the blanks here. The potential difference between 2 points in an electric field is the dash per dash in moving a charge from dash to dash. Okay, 4 filling the blanks. How many of you are going to get all of them? How many of you are going to get all of them? Come on. Think about it. The potential difference between 2 points in an electric field is the dash per dash in moving a charge from dash point to dash. Yes, the potential difference is the work done per unit charge, in moving the charge from, because it's potential difference. Don't use the word infinity. A lot of people write infinity. No, it's not just the potential, it's the potential difference. Be careful. So you take it from one point, move it to the other point, see how many joules of work was done and how much was the charge. Just divide them. You get the volts difference, potential difference. Unit of capacitance is the dash which is defined as 1 watt. What? Come on, think about it. Unit of capacitance. We all know it is farad. How do you define farad? Farad is, because Q is CV, C is Q by V. C is Q by V, charge by voltage. The 1 farad will be 1 coulomb of charge stored per volts. So 1 coulomb per volt, yes, 1 coulomb per volt, exactly. Farad, which is 1 coulomb per volt. Very good, very good. Next one coming up on your screen, and here it is. The potential energy stored in a capacitor is given by this, where V is not the unit. What is it called? That V. Many people will make a mistake in this. I know this. What is that V? Let's see how many of you get it. Let's see how many of you get it. Already some of you have started mentioning volts, voltage. No, the answer is not volts, voltage. The answer is voltage difference. See, understand there is a difference between potential or voltage versus potential difference or voltage difference. Whenever you write Q is equal to CV, what is that V? It stands for the difference in the voltage across those two terminals. Difference. If both the terminals are at 20 volts, then the voltage difference is 0. So there will be no charge only. Don't say, sir, voltage is 20. If both terminals have 20 volts, it is not 20 volts. The V value will be 0. So it is always voltage difference. That's one very important thing many students miss. Okay, very good. Series combination, the reciprocal of the total capacitance is the sum of the dash of the individual capacitance. A very simple word, very, very easy. Come on, think. What should be fill in the blank? The sum of the reciprocals, right? 1 by C1, 1 by C2, 1 by C3. They are reciprocals. So you take the sum of it, you get the reciprocal of the total capacitance. As simple as that. Moving on. If you take a parallel combination of capacitors, the total capacitance is the dash of the individual capacitance. The total capacitance is the dash of the individual capacitance. Come on, my dear warriors, think about it. Come on, my dear warriors, think about it. What do you think is the correct answer for this? In a parallel combination of capacitors, the total capacitance is the sum of the individual capacitance. You just add all the sum, you will get the total capacitance in parallel. C1 plus C2 plus C3 is CP. Electric potential due to a point charge Q at a distance R from the center, from the charge is given by V is equal to. What should V be equal to? Come on, my dear warriors. This is very straightforward. What is the formula for the potential? Everybody must be knowing this. Everybody must be knowing this. The formula for potential. Yes, it is KQ by R. KQ by R. That's it. As simple as that. Very good. Yeah. So, lone warrior, very good question. Oh, guys, anybody wants to answer lone warrior? What's the difference between battery and a capacitor? Both hold charge. That's what the claim is. No, it's not right. Capacitor holds charge. Battery does not hold charge. Battery stores the energy in the form of chemical. Electrical energy is stored in capacitor. The form of energy stored only is different. A battery, when it discharges, it converts the chemical energy. There is a chemical reaction occurring in that electrolytes, and that produces electrical energy. Whereas in the case of capacitor, electrical energy stored between the plates in the field converts itself into the electrical power or electrical energy into the resistors, which is eventually lost as heat. Number 3, you will also see a capacitor, when it discharges, the voltage keeps on reducing. But if it's a proper electrovoltaic cell, the EMF across it will always stay constant. That's the big difference. Okay. Moving on. Energy density in electric field is given by the energy density. Standard formula, joules per meter cube. That's energy density. Energy density, what is it? Yes, it is half epsilon E square. Half epsilon E square is the energy density, joules per meter cube. Electric potential at a point due to a system of charges is the dash sum of the potential due to individual charges. What is the right word? I know, Janvi, it looks easy once you have given the JEE attempt, right? But let's also take a step back for many students who probably you're not able to score that much. And sometimes even when you are scoring 95 percentile, you realize during the exam or after the exam, there were many small things which you need to cover up. And in the hurry or in the haste of getting a very good rank or good percentile and just doing only some PYQs or some problems, many people overlook some of the basics. So I think it's a good time we can assimilate in just 4 days. Just give me 4 days time. Let's assimilate all the basic concepts of entire 12th standard physics. Yes, we are going to do that. Algebraic sum. Yes, the electric potential at a point due to a system of charges is due to the algebraic sum. You just add V1 plus V2 plus V3. What is it? Algebraic sum. Correct. Or scalar sum. Yes, very good. Scalar will also do. Algebraic will also do. Yeah. I hope this is very clear. Awesome. The electric potential inside a conductor in electrostatic equilibrium, voltage inside a conductor, because field is not there, everywhere the voltage will be same, constant, same or constant. Correct. That is the correct answer, because field is not there. No field, no voltage change. Potential is same or constant throughout. If there is a dielectric material in a capacitor, then the effective electric field between the plates is, okay, the presence of a dielectric material in a capacitor dash the effective field. The moment you add a dielectric, the dielectric material reduces or decreases the field inside, because it creates an opposite induced field which opposes the external field. So the net electric field will go down because of the polarization. So it reduces. That is the perfect correct answer. In a capacitor, the electric field is the strongest at the dash of the plates. This is very tricky. Many people do not get it. Where do you think the electric field is the strongest for a capacitor plate? Come on. Where do you think it is? The correct answer, a lot of people are going to give, sir, everywhere it is the same. Some people think it is at the center. No, the answer is the edge. The edge. Whenever you have an edge, let's say this was one of the plate, then at the edge is sharp, and electric fields are very strong at sharp edges. That's a property of conductor. If the end is smooth or the conductor is smooth, it's curved nicely, field is okay. If it is having small radius or it is more curved, field is strong. If it is sharp, it's even stronger. Keep that in mind. Okay. So it's not negative plate or positive plate or anything, right? It is basically going to be your, yes, perfect. It's going to be your edges. Moving on, the ability of a capacitor to store charge is affected by the dash of the dash material used. This is very straightforward. Come on, my dear warriors. What is it? Yes, it is going to be dependent on or affected by the dielectric material's K value, the dielectric constant value. Very simple. Capacitance of a cylindrical capacitor depends on, what's the formula? It depends on the inner radius, the cylindrical capacitor, inner radius and outer radius, and one more thing, the height. Remember, the formula is 2 pi epsilon h divided by log b by a, log r1 by r2. So it's dependent on the radius of the cylinders and the length or the height. Yes, very good. No hurry, and you know what used to happen when 10 years back when I used to use the iPhone, no, students will say, sir, wow sir, iPhone sir. Nowadays when I show iPhone, no, then students are like, sir, which iPhone? 12 Pro Max, sir, what, which century are you in? You're still using that iPhone only. See, my dad gifted me this iPhone, sir. This is a Pro Max, and that too I got some 256 GB, I got 512 GB, 1 TB. Like, very good. I only don't use that. So no point. These days students only will flex. Unfortunately, you are in online mode right now, but if you're in offline in front of me, you would have also done that, I feel. Okay. In a capacitor, if the dielectric strength is exceeded, it leads to a phenomena called as, if the dielectric strength is exceeded, what does it cause? What does it cause? Come on, think. Yes, it calls for a breakdown, which happens during lightning, sudden discharge. Yes, perfect, perfect, perfect. Awesomeness. Those of you are also, Uchuk Puchuk, let me tell you, I hope you are a part of the JEE crash course, because right now in the phase 1, main focus is on the JEE preparation, that too 12 standard topics. So JEE preparation is going on in the JEE crash course. So if you have not yet joined, please watch the previous video, be a part of it. The entire JEE portion of 12th will be covered in the phase 1, then phase 2 is boards, phase 3 is 11th standard revision, phase 4 is final lap revision with mock test and complete revision and strategies just before the second attempt. Next one, the work done by an external force to move a charge in electric field against the electric force is stored as the dash energy. This is very straightforward. So electric field, you are storing the energy, it will be electrical potential energy only. That is like very obvious. Okay, let's just go on. If the distance between the plates of a parallel plate capacitor is half, remember the formula. Epsilon naught A by D is the capacitance. So denominator becomes half, denominator becomes small, the ratio becomes huge. Denominator becomes half, the ratio becomes double. So capacitance will be double. Capacitance will be doubled. Very good, guys. I can see many of you are probably answering it. Excellent. Next one coming up on your screen. The electric field due to infinitely long wire is proportional to the dash from the wire. Is proportional to the dash from the wire. Is proportional to what from the wire? The formula only is 2K, right? You have this electric field which is nothing but K, then you have lambda, and then there is R, and then there is 2 on the top. So 2K lambda by R. So what is the field proportional to? 1 by R. It is proportional to 1 by R. It's proportional to the inverse of the distance. Yes, perfect. Inverse of the distance. Yes, and it is proportional to the, see, the word used is from. If the word used is of the wire, then the answer will be lambda of the wire, charge density. If it was of the wire, it's a property of the wire. Lambda is of the wire. From, what is from the wire? Distance. So inversely proportional to the distance. Understood? So one small word will make a lot of difference. That's why filling the blanks are crazy. Yeah. Yes. Can NEET students join the crash course? Hold on, Arjit. Please don't join the crash course of JEE. I'll be doing something for you. Yes. JEE students are very happy with the JEE crash course. You need biology. So for NEET students, we'll be doing it separately on the NEET English channel where I'm only taking care. Don't worry. We'll be doing something this week itself. Stay tuned on that channel. The unit of dipole moment standard, charge into length, Coulomb meter, as simple as that. If you know the formula, you can easily guess the units. Field inside a charged spherical shell is 0. Electric field is 0. Then this is a consequence of which law? Because field is 0, flux is 0, flux is 0, charge enclosed is 0, charge enclosed is 0. How did you conclude? Which law did you use? You used Gauss's law. You use the Gauss's law, so hence it's a result of the Gauss law. In a parallel plate capacitor, the plate area is doubled, the capacitance is epsilon naught A by D, area doubled, capacitance also doubled, right? So the answer is doubled. Very, very good. Perfecto, my dear warriors. Next one. Electric potential at a point and distance r from a charged sphere, conductor, read it carefully, is the same as if all the charge were, if you are outside a conducting sphere, all the charge which is there on the periphery, on the circumference, on the surface will behave as if it is concentrated at the center. It behaves like a point charge, and the formula is used is kq by r square, where r is the distance from the center. So as if all the charge were at the center. Very good. Electric field is always dash to the dash surface at every point. What do you think? Electric field is always dash to the dash surface at every point. Yes, very good. Very good. It's always perpendicular to the equipotential surface at every point. Not parallel, it's perpendicular. If potential line is like this, electric field lines will be perpendicular at every point to the equipotential surface. That's another property between potential and field. Cool. Next, when a dielectric material is placed in external field, it gets, if you take a dielectric material and you place it in a field, what will happen? It will get polarities. That's how induced field is created. That's how the net field reduces. So it's getting dipoles, polarities. That means it is getting polarized, right? It's getting polarized. That should be the answer. Very good. Very good. Yes, perfect. Ramalingam, before every board paper, we'll be having board specific classes also, where we'll be doing a lot of things related to those boards, marathons, sessions, whatever it takes, right? Yes. When capacitors are connected in series, the total voltage is the dash across each capacitor. When capacitors are connected in series, the total voltage, not capacitance, voltage. Anything in series, V1, V2, V3, one after the other, you add V1, V2, V3, you get the total voltage. It's just the plain simple sum. You add the voltages, sum of the voltages, V1, V2, V3, you will get the total voltage. Work done to move a charge against the electric field stored as the dash in the electric field. Work done in moving a charge against the electric field is stored as, obviously, electrical potential. It has some ability to do work. You move the charge in the field, you leave it, it will start moving. How did it gain that energy? It was stored like a spring in the form of electrical potential, ability to do work. Gauss law is particularly useful for calculating fields of dash charge distribution. If you see Gauss's law, always it is used for infinitely long wires, spherical bodies, all those kind of things. What is so common in all of them? The common thing is they are all symmetrical. They are always having some kind of symmetry, right? A sphere has a three-dimensional symmetry. A shell, three-dimensional symmetry. A large sheet, whatever is there here is there here. A line charge, a symmetry in all the directions, right? So symmetry should be there. Capacitance of a cylindrical capacitor is given by, I think we just discussed this some time back. C is 2 pi epsilon naught, 2 pi epsilon naught divided by log b by a, and on the top you will also have length. 2 pi epsilon naught, bottom you have log b by a, and on the top you also have the length or the height of the cylinder which is there, right? Very good. Electric force between two charged particles is independent of a lot of things which it is independent of. One of the few things which it is independent of, come on. Electric force between two particles, it's independent of what? Other charges, whatever are there, doesn't matter. These two charges will always repel or attract with k, q1, q2 by r square. There is no third charge or third distance or any other thing in it. So it's independent of other charges. Okay. Electrical potential energy of two charges is positive if the charges are of what sign? Electrical potential energy. Energy is positive. Formula for energy is k, q1, q2 by r. So either both charges are positive or both charges are negative. That means the charges should be same. The charges should be of the same sign. Positive, positive, negative, negative. Positive, negative will make it negative potential energy. Principle stating that the total electrical charge of an isolated system remains constant is known as the dash of the dash. The principle stating that the total electric charge of an isolated system is called as which principle? Think about it. Yes, principle of conserving the charges. The charges can't go out, charges can't come in. What is that? Conservation of charges. That's one of the first few paragraphs in your chapter 1 of your 12th standard exam or 12th standard book. If you take an insulator like rubber, wood, etc., how do you charge it? What is that process called? If you want to charge rubber, what do? You rub it. You use the property of friction, right? So hence the answer for this wouldn't be friction or rubbing. Yes, you rub two things like plastic with wool and glass rod and all of those things. You rub, only then they get charged. You don't have to touch it, you have to rub it. Yes, it's not induction, it's not conduction, it is rubbing. It is rubbing. Understand that. How do you charge something or which is not a conductor? It is rubbing. Conductors, yes, you can use conduction. You just directly transfer. Field at the surface of a charged conductor is perpendicular to the surface and is given by, if you take a conductor which is there and the surface, if you take inside there is no field, outside a conductor, the formula is sigma by epsilon. There is no 2 over there. Yes, sigma by epsilon. There is no 2 in that formula. If it's a sheet, both the sides it will go, both means 2, so sigma by 2 epsilon. If you take the surface of a conductor, outside it is there, inside it is not there, only one side it is going, so there is no 2 in the formula, there is only 1 in the formula, 1 sigma by epsilon, that's it. That's how you can remember it. Yeah. Yes, Aki the beast, I will definitely be taking care of your English. Chemistry teachers will be taking care of your chemistry just before the boards. So imagine English paper is over. After that, let's say physics paper is there. So all those days physics preparation. Physics paper gets over. Chemistry exam is there. So all those days chemistry preparation. After chemistry again maths is there. So all the days maths preparation. That's how the schedule will look like. Day in day out classes. Oh, I think I just showed the answer. Anyways, we'll see that. Electric field at a point outside a charged thin shell is what? Inversely proportional to the square of the distance. Yes, inversely, because the formula only is kq by r square. Correct? Electric potential due to a dipole at a point on the axis depends on the dash and the dash of the dipole. Many things you can think of. Many things you can think of. Multiple answers can come over here. Multiple answers. If you take an axial point, what does it depend on? The strength of the dipole, right? The distance from the dipole. So many things it can depend on. Yes, one of the options is distance and the strength, because the formula is only kp into 2 divided by x cube. So it depends on p, which is dipole strength. It depends on x, which means the distance. Right? Very good. Moving on. Electric field line never intersect another field lines because the field at any point, why do they not intersect? Because if they did, then the field at that point is either here and here. So that ambiguity is there, that doubt is there. But we know field can be either here or here. It can't be both. So it's always unique. It's in a particular direction. So it's tangent and it is unique. It's always tangent and it's always unique. Hence, that's the correct answer. Moving on. Electric field due to a point charge decreases as the dash from the charge dash. Electrical field will decrease. How will the field decrease? Due to a charge. You go away from it. That means the distance from the charge is increasing. You are going away from it. That's what is happening. That's why the distance from the charge is increasing. That's how the field will slowly reduce. Next up. The work done to move a charge in an electric field is dash of the dash taken by the charge. The work done to move a charge in an electric field is dash of the dash taken by the charge. What do you think is the answer for this? Yeah, think carefully. Very good. Yes, it is independent of the path taken by the charge. Work done. It's a conservative field. So no matter how you go, doesn't matter. You go like this, you go like this, you go like this. Path taken does not matter. Work done is always the same because it is conservative. Let's go to current electricity. Ohm's law states that the dash through a conductor between 2 points is directly proportional to the dash across the 2 points. Come on. Let's do this. Quickly, let's complete current electricity too. Few questions remaining. Full Josh, full energy. Smash the like button right now if you have not done that. Everybody, show full enthusiasm, show full energy. I want to see the likes going up. I am seeing the session. Come on. I'm doing this all for you. Come on. Smash the like button right away, right now, even if you're watching it recorded. Very good. Ohm's law will state that the current through the conductor between 2 points is directly proportional to the voltage difference between the 2 points. Very simple. Moving on to the next one. Resistance of a conductor is inversely proportional to its dash and directly proportional to its dash. Resistance is proportional to what? Resistance is proportional to rho L by A. It's proportional to length, inversely proportional to area. Directly proportional to its, I think it has interchanged the answer. Actually, it should be inversely proportional to the area, directly proportional to the length. I'll get it corrected, don't worry. Next one. Parallel circuit is there and the total current is the dash of the current in the individual branch. Parallel circuit. You have parallel circuit like this. Yes, what do you think is the answer for it? Where is it gone? Yeah. What do you think is the answer? In a parallel circuit, what will happen? The current will get distributed. So each current, if you add I1, I2, I3 using Kirchhoff's current law, you will get What will get? We'll get the total current. So it's the sum of the currents. The answer is sum of the current. Very good, very good, very good. Very good, Akanka. Very good, Amuta. Very good, Dr. Sid. Very good, Bhargavi, anonymous helper. Wow, very nice. Okay. Kirchhoff's first law is known as the junction rule, is based on the conservation of. Junction rule, which is Kirchhoff's current law, what is this based on? Is based on the conservation of charges. Conservation of charges, correct. Very good. Next, rate at which electrical energy is converted to another form of energy. Rate of electrical energy getting converted into another form. Current goes through a resistor. That resistor gets hot, so heat is developed per unit time. So heat, which is joules per unit time, which is seconds, joules per second, watts. So the rate at which energy is getting converted into some form, that is the power of electricity, that is the electrical power. Yes, the filling the blank will be electrical power. Very good. No, not charge. No, no, no. It is power, electrical power. Be careful. Next one. Resistance of a conductor varies with the temperature according to the formula R is equal to where alpha is. Everybody recollect the formula. How does the resistance change? How does the resistance change? Yes, of a conductor. R is equal to R naught 1 plus alpha delta T, and alpha is the thermal coefficient of resistance. Yes, alpha is the thermal coefficient of resistance. Very good. If you take an ammeter, how should you connect it with the circuit to measure the current? Ammeter. Do you connect it along with the circuit or parallel to the circuit? You are measuring current through the circuit, you will connect it in series, it will have very low resistance. Voltmeter is always connected in parallel, hence the answer will be in series with the circuit. In series with the circuit. Yes, perfecto, perfecto. Next one, reciprocal of resistance. Many people are going to give wrong answer. Let's see what your answers are. Start spamming in the chat box. Start spamming in the chat box. What do you think is the reciprocal of resistance called as? Many students are going to give it wrong. Doesn't matter whether you are a board student, JEE student, doesn't matter. Yeah, 1 by rho is sigma, that is resistivity's reciprocal is conductivity. 1 by R, reciprocal is not conductivity, it is conductance. It is conductance, not conductivity. Conductivity is reciprocal of resistivity. Very good. Now you guys got it. Drift velocity increases because dash applied to the conductor increases. What happens? Why does the electrons drift faster? Because there is more force on it. That means there is stronger field. That means there is more voltage. So because what increases or what is applied? Electric field is applied, or other filling the blank could be voltage is applied. Voltage difference is applied. Correct? So both can be correct. Kirchhoff's second law, also known as the loop rule, is based on the principle of conservation of what? Is based on the principle of conservation of what? Come on, my dear warriors. What do you think is the correct answer for this? What do you think is the correct answer for this? Come on, tell me. Yes, it is known as the principle, it is also called as the Kirchhoff's voltage law. It is based on energy conservation. It is based on the energy conservation. Very good, Amita, Hariyar and Janvi. Awesome. Moving on. Next one. The process of converting alternating current, into directional current is known as AC to DC. AC to DC, that is there in semiconductors, that is called as rectification. What is it called? Rectification. Yes. The inverse process, how many of you know? If you take DC, you convert it into AC, what is it called? Put it up in the chat box. Let me see how many of you know this. If you take DC and you convert it into AC, what do you think is the answer? Many people might not know this. This is called as inversion. You might have heard of the word inverter. When electricity goes in your house, what do they say? Oh, turn on the inverter, or the inverter is making noise. So there are some batteries and your light bulbs, light up. So there is an inverter. What does it do? There are batteries, that is DC. It converts it into AC, which is used in your house. So that is inverter. Opposite of rectifier. The product of current and voltage in a circuit is the measure of electrical what? Current and voltage. What do you get? IV. Yes, IV. V into I is power, P. Yes. The answer for this is power. Power is VI, it is V squared by R or I squared R. All three formulas you should be remembering it. Voltmeter has a very high dash to ensure it does not affect the circuit it is measuring. What does a voltmeter do? It measures voltage. How is it connected? It is connected in parallel. So it is in parallel, so it should not allow current to pass through it. That means it should have a very high resistance. So answer for that is a very high resistance. Very good. Many of you answered it. If you take an ammeter, that too ideal, what do you think is the resistance of it? What do you think is the resistance of it? Yes, if you take an ammeter, it's connected in series. If it has good resistance, oh, it's going to change the parameters. So it should have very, very low resistance. Ideally, it should have no resistance or zero resistance. The answer here will be 0 or low resistance. Next one. The law which states that the algebraic sum of the voltages around a closed loop in a circuit must be 0 is known as Kirchhoff's. Which law? What is it? Which law is it? Come on, my dear warriors. Which law is it? Second law, which is also Kirchhoff's voltage law. KVL, right? KVL, Kirchhoff's second law. Perfect. Next one. Because V1 plus V2 plus V3 plus V4, V5, V6, you come back to the same point, the total sum is 0, that is KVL. In a circuit, the point where 3 or more conductors meet, what is that point called? When you take a point and many conductors are meeting, that point, what is it called? Node or a junction. Node is also correct, junction is also correct. Both words can fit in node or a junction. Okay, keep these points in mind. Resistivity of a conductor increases with an increase in what? Which quantity it is? If you take a conductor, you see the resistance is going up. On doing what does the resistance go up? Obviously increasing the temperature. Temperature if you increase, collisions increase, more difficult for the electrons to pass by, that automatically increases the resistance. The heat which you generate in a resistor is directly proportional to the square of the current. As per which law? There is a law. No, the answer is not area or length. A lot of people gave the wrong answer. So the resistance increases with the increase in. See, please understand, this was resistivity, not resistance. Resistivity. If the word used was resistance, then you could have said length increases, area decreases. Rho is a material property and it also depends on the temperature. So understand, the answer can't be length or area because changing length or area will not change resistivity. It is a material property and it only depends on the material and the temperature. Okay, so please don't write length or area. That will be wrong. See, that's the reason why you should attend these classes. These are all small things. And if you're watching this session, even joining in late or thinking, sir, is this of any use for me if I'm a JEE student? Understand, a lot of students, I mentioned this before, overlook the basic things and they, after first attempt, they immediately jump to the second attempt, and that too solving those kind of things which you might not be so comfortable with. Even if you are 95, 98, 94 percentile, understand there are many things you would not have dealt with properly, maybe by fluke few questions you got, maybe you use some elimination, maybe it just so happened that you were able to predict some of the questions and you got it, but you don't know how the next attempt will be. So better thing to do is take a step back and see the bigger picture and do everything in detail. Just don't do it as a one shot, just don't do it as a thing to, just as a task to do or just for the sake of doing it. Yeah, it is Joule's law, perfect. The answer is Joule's law. Many of you wrote Joule's, perfect. Energy per unit charge provided by a battery to move the charge through a circuit is called as battery's what? If you take a battery and you move a charge around the circuit, the energy per charge, joules per coulomb, you'll be like, sir, is it not called a voltage? No, read the question carefully. Joules per coulomb by a battery. What does a battery do? Battery provides energy, and that energy provided per coulomb is called as the EMF of the battery. Yes, the answer will be no. If you write potential difference 0, negative marks, not even like half mark, negative. It is called as the battery's property. A battery does not have voltage difference. Yes, there is terminal voltage which is developed, but what does a battery provide? provides EMF, electromotive force. Device used to introduce a known resistance into a circuit is called as an, a lot of people might not know this instrument. What is it called? A device which is used to create an artificial resistance. You will be like, sir, resistor. Yeah, you can say that, but that device, you might have held it in your lab, heavy one, bulky one, a lot of pins in it. You remove those pins, you can change the resistance. That is a rheostat. That is a rheostat. R-H-E-O-S-T-A-T, rheostat. Rheostat is that device which artificially creates a resistance in the circuit. It's a bulky, heavy device. You might have seen that in the lab. Resistance offered by an electrolyte in an electrochemical cell is, if you take any cell, lithium ion, whatever cell, inside that electrolyte there is some resistance. So when the current goes through the battery, not outside, within the battery, it encounters some kind of resistance. Because it is inside, obviously it is going to be called as the internal resistance. Internal. Graph of voltage and current and voltage is drawn. Then the slope of the graph will give you what? A lot of people are going to answer this wrong. Let me just show this for you. Okay, so you are drawing the graph of current versus voltage, and it is a straight line, and the question is, what is the slope going to be? Here the slope will be y-axis, which is current, divided by x-axis, which is voltage. Voltage is I into R. I cancelled, so it will be 1 by R. So a lot of you might be thinking, sir, the slope was resistance. No, the slope is 1 by resistance, or you can call it as just conductance, or you can just call it as conductance. So that would be the appropriate word. If you answer R, then -1. If you answer 1 by R, then +4. See, such tricky things. Device that converts energy, electrical, into mechanical energy. There are many devices. What is the most commonly used device which converts electrical energy into mechanical energy? See, if it was electrical energy into heat energy, you will be like, sir, it is a resistor or a heater coil, right? It converts electrical into heat. If it is doing electrical into mechanical work, that's used everywhere these days. Electrical cars, right? What is it made of? Motors. So the answer for this is a motor, electric motor. Very good. Many of you got it right. The total capacitance of capacitors in series is less than the capacitance of the dash capacitors in series. So when you have capacitors in series, the formula that you use is resistors in parallel. So 1 by C1, 1 by C2, 1 by C3. So the equivalent capacitance will be, I think, less, right? The equivalent capacitance will be less. So hence the answer will be less than the individual capacitors. Answer over here will be individual. Yes, individual will be the correct answer. Next one. The phenomena where an electrical current creates magnetic field. That's very simple. Current creating magnetism, electromagnetic property. Electromagnet. That's what an electromagnet is, right? You pass current in a coil, it behaves like a magnet. Oh, it's an electromagnet. So that phenomena, that property, that's electromagnetic property. To protect circuit from more current, over current, what do you use? What do you use? Yes, what do you use at your homes? You suddenly see a lot of current passes, suddenly high voltage fluctuation. Then you go downstairs and you remove one ceramic thing. What is it having inside? It has a fuse wire. The fuse wire has a low melting point and it melts if the current increases. Yes. Resistivity of a conductor dash with an increase in temperature. Obviously, when you increase the temperature, more collisions, more difficult for the electrons to go. So resistance will obviously increase. Resistance will increase. That's the answer for this question. Moving on. A device which limits the flow of the current to a certain level in a circuit is called as, what do you call that device, my dear warriors? Perfect, perfect. Come on, come on, come on. What is the answer for this? What is the answer for this? Come on and smash the like button if you are new to the session. Show your love, show your support. What do you guys do? Don't give Guru Dakshina only. One simple like you have to do. That's it. Smash the like button, or else how will the knowledge transfer happen? Yeah, the answer is resistor. A resistor limits the current. Correct. The total resistance for parallel is always dash than the smallest resistance. Whenever resistors are in parallel, the formula is 1 by R1, 1 by R2, 1 by R3 is 1 by R equivalent. So the final R equivalent is less than R1, less than R2, less than R3, every single resistor. So it is less than all the resistance, is always less than the smallest of the resistance as well. If you take an ammeter, it has some dash resistance to ensure accurate current is measured in the circuit. Ideal ammeter has negligible, zero resistance. So an ideal ammeter has zero resistance to measure the current accurately. Voltmeter ideally has infinite resistance. So answer here is 0. If it was voltmeter, answer will be infinity. A material with resistance that changes the temperature is called material which changes the temperature. What is it called? There are only two types of materials. One is conductor, second is semiconductor. So here you can put semiconductor or conductor, both will work. Both will work. Okay, you change the temperature. For a conductor, when you increase the temperature, resistance increases. But for a semiconductor, it's opposite. When you increase the temperature of a semiconductor, the resistance goes down. So be careful about it. Next one. SI unit for measuring electrical conductance. SI unit. How many of you know this answer? Let's see. Spam the answer in the chat box. Yeah, both you can use, Pratham. Conductor also, semiconductor also. Dev Narayan. You can also put conductor, semiconductor. If it's a multiple choice, one option says conductor, one option says semiconductor, one option says none, other option says both, A and B. Then you will mark both A and B. Okay, that's how it will be. Yeah, the correct answer is Siemens. Siemens is the unit of conductance. Keep that in mind. Siemens. Yeah. Phenomena of an electric current flowing through a vacuum or a gas is known as. When current flows through a vacuum or gas, what is it called? Like lightning. That is electrical breakdown, electrical discharge. Usually current does not flow through wood, air, vacuum. No, current needs a conductor. But even if conductor is not there, still it is flowing. That means there is so large voltage, such strong field that breakdown occurred and discharge occurred. So breakdown and discharge will be the correct answer for this. When you dissipate electrical energy in the conductor, it is often released in the form of, when a current flows through a resistor, which form of energy do you usually get? Yes, I squared R losses, heat loss. So it's usually released in the form of heat. That is the correct answer. Heat, joules is released, correct. A galvanometer can be converted into a voltmeter by connecting a dash resistor in series with it. If you take a galvanometer, you want to convert it into a voltmeter, then you connect a very high, strong, large resistor in series with it. So, because it's a voltmeter, you connect a large resistor in series with it. If it was ammeter, then the answer will be shunt resistance in parallel with it, or low resistance in parallel with it. That is if it was an ammeter. Okay, voltmeter will be high resistance. Ammeter will be low resistor, that too in parallel. Okay, so that was the end of the session. All the questions will be available in the PDF form in the Telegram group. So make sure you are practicing the questions, giving the quizzes, be a part of the channel and get all the benefits, that too at absolutely free of cost, purely academic content. That means you are staying away from distractions and getting the latest information, updated news on time to time basis. So all the best. Make sure you are a part of the Telegram channel. Link is there in the description box below. And I will be updating you about a big surprise very soon. Okay. So take care. Have your dinner quickly and we'll meet also soon. Bye bye. Hasta la vista, Captain Shreyas signing off. Do not forget to like, subscribe and join. Bye bye.